Hello students, and you are welcome back to Solve Your Physics Past Question class. Today we continue on the aspect of projectile to better our understanding on the concept of projectile to solve any external examination coming your ways. And we'll be taking a question from our West African Examination Council past question across the years 2000 to 2010. So the first question we have in today's class is: a projectile is launched horizontally from a height of 80 meter with a speed of 25 meter per second. Determine the horizontal distance traveled given acceleration due to gravity to be 10 meter per second square. Now, the first thing for us to note or to find is that you have to find the time to reach the ground. Remember, we're told to determine the horizontal distance. So we have to find the time, all right, to reach the ground. Now, the first thing for us to do to find the time to reach the ground, you can use the height formula, which is h is equals to half gt squared. So using this, since we're given our height and we're given acceleration due to gravity, then we can find our time to reach the ground, a time for the projectile launched to reach the ground. So we have plugging in our height, which is 80, and our g, which is 10. So we have 80 is equals to half times 10 times t squared. So when you divide through by 2 at the right hand side, you'll be having 80 is equals to 5t squared. Then when you divide through by 5, you're having t squared equals to 80 divided by 5, and that will be 16. So the next thing for us to do is to square root both sides. So you have t is equal to square root of 16. So our t, that is the time to reach for the projectile launch to reach the ground, will be 4 seconds. Now, the next thing for us to do is to calculate our horizontal distance. So to calculate our horizontal distance, so we have d is equals to vx, that is the initial velocity on horizontal component, times the time for the projectile launch to reach the ground. So that will be d equals to vx times t. So vx, that is the initial velocity in an horizontal component. That will be 25 given from our question, then times t, which is the time for the projectile launch to reach the ground. That's 4. So that will be 25 times 4, and that will be 100 meter. So 100 meter is the horizontal distance covered by the projectile launched from our question. The next question we'll be solving in today's class says a projectile is fired with an initial velocity of 30 meters per second at an angle of 20 degrees. Calculate the horizontal range. So given acceleration due to gravity to be 10 meters per second squared. Now, to calculate the horizontal range, you must understand that the horizontal and vertical component of the initial velocity must be calculated. So that means we have to calculate Vx, which is the horizontal, and Vy, which is the vertical. So let's start with the Vx. So Vx equals to V cos theta. So that will be the velocity given from our questions is 30 meters per second. So that will be 30 cos 20 degree. So that will be 30 times 0.397. That's the value for cos 30. So that will give you 28.19 meter per second. That's the initial velocity on the horizontal component. So now we have to calculate initial velocity on the vertical component. That's Vy. So that'll be Vy is equals to V sine theta. So that'll be 30 sine 20. So that'll be 30 times 0.3420. So that'll give you 10.26 meter per second. Now, to calculate these, then, the next thing for us to do is to calculate the time of flight. The time of flight will help us to calculate our horizontal range or our range. To get the time of flight, we use the formula t is equals to 2 times the initial velocity at the vertical component, then all divided by g. So that will be 2 times 10.26 divided by 10. So that will give you, divide through, that will give you 2.05 seconds as the answer for time of flight. Now, remember I said the time of flight will help us to calculate our range. So to calculate the range, we then have range is equals to the initial velocity of the horizontal component, then times the time of flight. So that will be 28.19 times 2.05. Now, when we calculate this, we have the final answer to be 57.8 meter as our final answer. Next question we'll be solving in today's class says a ball is thrown at a speed of 40 meters per second at an angle of 37 degrees. Calculate the maximum height attained by the ball, given acceleration due to gravity to be 10 meters per second square. Now, to calculate this, we know that the ball which is thrown at random, and to calculate uh, the maximum height. So we need to find a vertical component of the initial velocity first, which we use to calculate our maximum height. So to calculate the initial velocity at the vertical component, so you have Vy equals to V sine theta. Remember from our question, our velocity is given as 40 and our theta is given as 37. So we have 40 sine 37. So that will be 40 times 0.6018. Then 40 times 0.6018 will give us 24.07 meter per second. So therefore, the next thing for us to do is to calculate our maximum height. So the maximum height as h will be therefore be the square of the vertical component, all divided by 2g. So that will be Vy square of V square y divided by 2g. So that will be 24.07 square divided by 2g. That will be 2 times 10. So that will be 24.07 squared times 24.07. So that will be that's 579.36 all divided by 20. So final answer therefore approximately should be 28.97 meter.